Welcome to our deep dive. We're here to sift through your sources and really pull out the core insights for you. And today, we're looking at something really critical, I think. The future of healthcare AI, specifically in India.
Yeah, it's fascinating stuff. And, looking through these sources, one thing just hits you straight away. It's this huge foundational challenge. It's not really just about the cool AI algorithms. It's the ground game.
The ground game,
Building the infrastructure, internet access, the IT systems that are already there. Especially when you get outside the big cities in India, that's where the sources really focus the challenge.
Okay, right. So let's unpack that. Our goal here, for you listening, is to really dig into what these sources say about those specific hurdles, the infrastructure, the connectivity, and maybe more importantly, look at the clever ways people are trying to get around them. This feels like where it gets really practical and honestly pretty interesting.
Exactly. I mean, the sources are really clear on this. You can't just drop AI into a hospital and expect magic. It needs support. It needs, solid IT infrastructure underneath it. And it has to be able to connect smoothly with the systems that doctors and clinics are, already using day to day.
So it's not just the shiny new object. It's how it plugs into everything else. Makes sense. But even before integration, these sources seem to flag something even more basic, don't they? Just getting connected at all.
Oh, absolutely. That's probably the biggest single issue highlighted. Large parts of India, particularly rural areas, they just face real limits on reliable internet and even just access to decent computers sometimes. So figuring out how to make AI work effectively when you don't have great bandwidth, that's a major puzzle they're trying to solve.
And why is that specifically such a problem for healthcare AI? I mean, slow internet is annoying, but here it sounds critical.
It is. Because a lot of AI, especially the more powerful stuff, it often works by sending huge amounts of data somewhere else, usually the cloud for processing. Think about patient records, medical images like X-rays, maybe even live video feeds from a remote checkup. Sending that reliably over a shaky connection, it's tough.
Right.
The sources give an example, systems for monitoring patients after they leave the hospital.
Yeah.
Those need to send updates reliably, right? Even if the internet connection at the patient's home is weak or intermittent.
Yeah, I can absolutely see that. If you're a doctor trying to keep tabs on someone remotely, that data just has to get through reliably, quickly.
Exactly. Or think about remote patient monitoring, where maybe you're streaming vital signs like heart rate or oxygen levels constantly. You need a rock-solid connection for that to be usable. And another example they mentioned was paramedics and ambulances using telemedicine. So they might need to share data in real time, maybe get a specialist on a video call from the hospital while they're on the move. All of that just completely depends on having a stable internet link in a moving vehicle, often outside cities.
Wow, yeah. When you put it like that.
Without that link, those really valuable, potentially life-saving things become, incredibly difficult, maybe impossible.
Okay, so connectivity is hurdle number one. Getting the data to the AI or the AI analysis back, big challenge. But then the sources seem to pivot a bit, right, to the data itself, even if you have a connection.
That's right. Yeah. The next piece is interoperability. Fancy word, but it basically means getting different computer systems to talk to each other and share data smoothly. Because AI, to be really smart, needs data from lots of different places.
Like what kind of places? The sources mention specifics.
Yeah, they did. Things like the main electronic health record or EHR system, the results from the diagnostic machines like imaging, MRI, CT scans, the lab systems. AI needs to pull all that together. And to do that, you need what are called APIs, application programming interfaces, essentially, the technical handshakes that let different software systems share information. And you need good integration layers.
Okay, like translators between systems.
Yeah.
And what's a specific challenge there in India, according to the sources?
Well, they point out that standardized electronic health record systems, their adoption is still a work in progress across the country. It's getting better, but it's not universal. So what you often find is patient data is kind of fragmented. It might be split across different clinics, different hospitals, stored in different software, using different codes or formats. So just finding and pulling together a complete standardized health record for a patient, which is basically the fuel AI runs on that, can be really, really difficult. It's like trying to build a puzzle with pieces missing, and the pieces you do have don't quite fit.
Got it. So hurdle one is the network pipes. Hurdle 2 is getting clean, complete data to flow through those pipes, even if they exist. Another infrastructure problem, really.
Precisely. It highlights why having a unified digital health system is so important. And actually, your sources bring up a really key government initiative aimed right at this problem. The Ayushman Bharat Digital Mission, or ABDM.
ABDM. Okay, that sounds significant. What's the goal there?
The big picture goal is to build a unified digital health infrastructure for the whole country, creating standards, enabling data sharing, basically building the digital roads needed for everything else. The sources really frame it as a crucial step, making digital health more common, making data more available, and yes, laying that foundation, that fundamental infrastructure that you absolutely need if you want AI to be widely adopted and effective down the line.
Building the highway before you can have lots of complex traffic running on it. Makes sense. But okay, that sounds like a huge, long-term project. What about now?
The sources also talk about clever ways people are working within the current limits, right? Bridging the gap while that bigger infrastructure gets built.
Yes, and this is where it gets quite innovative, actually. They detail several strategies. One big one is deliberately designing AI applications for low-bandwidth situations.
How do you do that?
Well, things like optimizing the data that gets sent, maybe compressing it heavily, or only sending essential summaries, using lighter apps that just don't require as much data transfer, or, and this is key, doing more of the processing locally, right there on the device in the clinic or hospital, instead of needing to send everything off to the cloud first.
Right, processing at the edge, as they sometimes call it, turning the constraint into part of the design. Smart. What else?
Another crucial one is building in robust offline functionality.
Meaning, the critical parts of the system have to keep working even if the internet connection drops completely. Think back to that ambulance example, the monitoring has to continue.
You can't have it just die.
Exactly. Or those post-discharge monitoring systems, maybe they need to store the data securely offline when there's no signal, and then automatically sync it up later when a connection becomes available.
So it doesn't lose data, it just waits. Clever.
And related to that local processing idea is edge computing, which the sources mention. This helps deal with both dodgy connectivity and maybe not having super powerful computers locally. Instead of sending, say, raw video from a remote console all the way to the cloud for analysis, edge computing means doing some of that analysis, maybe initial filtering or identifying key moments closer to the source, on a local server or even a powerful local device.
So you only send the important bits over the potentially slow link.
Exactly. Saves bandwidth, saves time, reduces reliance on that constant cloud connection.
But they're not saying abandon the cloud entirely, are they? The sources still see a role for it.
Oh, definitely not. Where good connectivity is available, using cloud infrastructure is still seen as vital for scalability, handling more users, more data easily, and often for cost effectiveness. But the sources always add that caveat. You need the connectivity to get to the cloud resources. It's the bottleneck. And they also make a specific point about data localization, the need to use data centers located in India to comply with regulations.
Right, that data sovereignty point is huge these days. Any other practical design strategies mentioned?
Yes, a mobile-first approach. This comes up strongly.
Because so many healthcare workers use smartphones.
Precisely. The sources point out that smartphones are often the primary computing device for many health workers across India. So any AI tool or interface has to be really user-friendly and work well on a mobile screen, often over those mobile networks, which might be, again, low bandwidth.
Makes total sense. Designed for the tools people actually have and use. I guess underlying all this is cost, right? It has to be affordable.
Absolutely critical. The sources really hammer this home. Solutions need to be accessible financially for everyone, from the big city hospital to the small rural clinic. They specifically mention things like using open source AI platforms and tools as one way to potentially bring down the costs of development and deployment, making it easier for more places to adopt these technologies.
Okay, so if you put all that together, the connectivity issues, the data fragmentation, the big ABDM initiative, and then these really practical strategies like offline modes, edge computing, mobile first. What's the overall approach the sources say is needed?
It really paints a picture of needing a very pragmatic, multi-layered strategy, not just one silver bullet. Key elements seem to be taking a phased approach, Start small, test things out in the real world, learn, iterate quickly, don't try to boil the ocean. Also focusing on integrating with the systems people already use rather than demanding a complete overhaul overnight.
Yeah.
Tackling those data quality and standardization issues head on is essential. You can't build good AI on bad data. And maybe the most fundamental point they make is that solutions have to be designed specifically for the Indian context, for the infrastructure realities, the specific clinical workflows. You can't just copy-paste something that was built for, say, Northern Europe or the US and expect it to work seamlessly.
It sounds like it's so much more than just writing clever code then.
Oh, absolutely. The sources really stress that this needs deep collaboration. You need the healthcare providers, the doctors, the nurses bringing their real-world knowledge. You need the IT developers building these resilient, context-aware systems. And you need the policymakers creating the right environment and supporting that infrastructure build-out. And crucially, you need to build trust, involving clinicians early, making sure they understand the tools, that the tools actually help them. That's vital for getting these things actually used. Acceptance is key.
That's a really clear picture. It feels like the potential for AI in Indian healthcare is massive, truly transformative perhaps, but actually getting there means methodically tackling these foundational issues first: the connectivity, the data, the integration, making it work for the reality on the ground.
Exactly. It's about adaptability, resilience, designing for the specific conditions across the country. That seems to be the core message from your sources for unlocking AI's potential for everyone, not just in a few select places.
What a great summary. And, it leaves you with a thought, doesn't it? Beyond just India, beyond just healthcare, think about how that very need to innovate under constraints, whether it's limited internet, patchy data, fewer resources, how that pressure often forces the creation of solutions that are maybe not just workarounds, but actually better in some ways, more robust, more efficient, more adaptable.
That's a really interesting angle.
Solutions born from necessity that might end up having applications in all sorts of other challenging environments around the world. Something for you to think about. What other problems could we solve if we design technology for the ground truth where it's used, instead of assuming ideal conditions? Thank you for joining us on this deep dive.